Right, section 1.4, trigonometry for all angles. This is one of my favorite sections in trigonometry. It's taking everything we learned in section 1.1, 1.2, 1.3, it combines it all together in this nice, neat little package, and it's usable in the future. So this is a really fun section for me, and I think if you let it be fun, it can be a lot of fun. So here we go. Let's get started. Intro to reference angles. So we talked about reference triangles before. Let me go back to when we talked about them. Boom, 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 boom. We talked about reference. Oh, I was already there. We talked about reference triangles before. I found this fun little picture on the internet. Reference triangles are always drawn to the x-axis, so they're part of this bow tie. I'm going to use this bow tie idea for the rest of ever. I learned that new this semester, and I've been teaching for over 10 years. Anyway, reference triangles were these triangles that we made where they hit the unit circle, the radius was 1, so the hypotenuse was 1, and they made these right triangles, and we used those to find out information about angles that were not in the first quadrant. We're going to use that same exact idea, but now instead of looking at it as if it were a triangle, we're just looking at this angle right here, just kind of looking at it for different reasons. Sometimes because we're going to do something with a triangle, sometimes for other reasons. But reference angles are very, very important. So the reference angle is always going to be the angle made with the x-axis and the terminal side of theta. So reference angles are always between 0 and 90 degrees. This is really important if you're doing an exam and you say that a reference angle is negative or a reference angle is over 90 degrees, then you should immediately have a feeling like, oh, that doesn't sound right, because it's not, because they're always 0 and 90. So depending on which terminal side, which quadrant you terminate in, you'll have different reference angles. And they're always part of this bow tie. So why are reference angles useful? Well, my friend, let me tell you. They're useful because we know information about these, these three angles in the first quadrant, the 30, 45, 60 degree angles. We know their sine values, their cosine values, their tangent values. But there are other angles within this unit circle where their reference angle is the same as one of the 30, 45, or 60 angles. And because that's true, if we make a little triangle here, right, the values that would be for this 45-degree triangle, if there were a 45-degree triangle here, we would have square root 2 over 2, square root 2 over 2, and 1, right? Here, if we still made this hypotenuse 1, if this is a 45-degree angle and the hypotenuse is 1, the length of this side and this side have to be the same as over here. They have to be, because it has the same angle measures and we already know one of the sides. So they have to be the same triangle. So we know that this side length is root 2 over 2. We know this side length is root 2 over 2. And it allows us to find this coordinate point, x comma y. It allows us to find this coordinate point, x comma y, using the fact that we know what the sides of these triangles are. Now, we're in the second quadrant, and in the second quadrant, x is supposed to be negative and y is positive. So it would be negative square root 2 over 2, comma, positive square root 2 over 2 for that coordinate point. And if you look here, right, so 135 degrees, this reference angle that we got here, or this original angle that we had here, the reference angle is 45 degrees, because you would go 180 degrees from here to here. This is 180. And we know that from here to here is 135. So if you did on a calculator, 180 degrees minus 135 degrees, that's where that 45-degree reference angle is coming from. And notice these values are the same value. It's the same number, just different signs. Cosine of 45 is square root 2 over 2. We already know that. Cosine of 135 is negative square root 2 over 2. The number part is the same. Tangent of 45 degrees is 1. Tangent of 135 degrees is negative 1. So same value, just different signs, depending on the quadrant that it's in. So this gets used extensively, because if we can boil everything down to its purest form, to its first quadrant form, deal with its first quadrant form, and then apply signs later, that means that we don't really have to think too much about 3/4 of the unit circle. We can focus in all of our energy right here in this first quadrant and then apply signs as necessary. So that's what we're going to be doing in this section. Um, Join me in the next video and we'll start talking about reference angles, how to find them, and then fun things we can do with them. All right, bye.